This is introductory econometrics. Topic: proof of OLS estimator, beta 2 formula. Here we want to prove that beta 2 adds is equal to summation x y minus n x bar y bar over summation x squared minus n x bar squared. Is equivalent to this expression, that is summation x minus x bar in bracket y minus y bar in brackets divided by summation x minus x bar in bracket square. So here is the solution. So let's start from the numerator. So here is it from the numerator. Here we have summation xy minus n x bar y bar. So we can manipulate this numerator to become this. So what do we do? So we have this same expression from here to here. Then we have summation xy minus n x bar y bar. So this is the exact expression we have here. So this is the addition to this. So the same thing, if you look at this one, we have minus n x bar y bar plus n x bar y bar. So if you look at this part, it's equivalent to 0. So it's like adding nothing to this expression. So this expression is equivalent to this expression. So now we can now use the fact that this x bar is equal to summation x over n, and y bar is equal to summation y over y. I mean, summation y over n. So look at this one. We have summation x, y. This is the same thing we have here. This minus, we have minus here. And this y bar, that is what we have here. And this n, that is what we have here. Now, we are left with x bar. So this x bar can be written as summation x over n. So meaning that the same thing we have here, that is what we have here. So now minus this minus n, we have x bar, this x bar. Now we are writing y bar as summation y over n. Plus this plus, we have n x bar, y bar. So next, we try to rewrite this. So we have summation x, y minus, but look at, if you look at this, we have n here, we have n. So this n, we cancel this n. So that is why we have y bar summation x. So we are left with y bar summation x, since n here has cancelled this n here. So we have minus here. Now this n also cancel this n here. So we have, we are left with x bar summation y plus n x bar y bar. So next, we are going to factor out summation. So we have summation here, we have summation here, we have summation here, and we have n here, which is also equivalent to summation. So if we factor out summation here, so we are going to have summation outside the bracket, we have xy, that's what we have here, minus, we have this y bar here, and we have x here, since we have already factored out summation outside. So we have minus here, we have x bar here. So this summation, so we already have it outside, so we have y plus this n is equivalent to summation, so we already have it outside. So we are left with x bar, y bar. So we close the bracket. So next thing is grouping. So we want to group this expression into two. So the first group, we have this part, that is x. Summation is still outside, open the bracket. So we have the first group, x, y, this x, y. So we have this y bar x minus, so the second group here, so we have x bar y minus x bar y bar. So we have minus here because, so that when we open the bracket, so we go back to this. So now, next, we still have to factor out the common element in each of the groups here. So we have summation outside here. So we have x bar here, x bar is common here, but here x is common. So we have here in this element and this element, we have x common. So we factor out x. So we are left with y minus, we are left with y bar here. So minus here. So we also factor out x bar that is common here. So we have x bar outside the bracket. So we open the bracket, we write y minus, we are left with y bar here. So we close the bracket. So now we can see that summation here, we write the summation here. So we now have this x minus x bar here. We close the bracket. So we also have y minus y bar here. So we close the bracket. So that is for the numerator. So we can see that this expression here, so is equivalent to this expression here, meaning that the same thing we have as the numerator here. So it's the same thing that we have here, that meaning that this expression here in the numerator is equivalent to what? The numerator of this expression here. So next is to show that the expression here, that is the denominator, is also equivalent to denominator here. That is summation x squared minus n x bar squared is equivalent to summation x minus x bar in bracket squared. That's what we want to show now. Now, we say from the denominator, so we have x squared minus n x bar squared. So here, now, so we are going to use the same manipulation we used in the other one. So we are going to write this expression here. So we have this expression that is summation x squared minus n x bar squared. So that is the same expression we have here, as in the denominator. Now we had this minus n x bar squared plus n x bar squared. So this and this, we see that this and this, that's minus n x bar squared plus n x bar squared. So it's equal to 0. This is equal to 0. It's like adding nothing to this expression here. So meaning that this expression is equivalent to this expression. So we write this as summation x squared minus n. We can see that this x bar squared is equivalent to x bar times x bar. So meaning that this n x bar squared is equivalent to this component. So we have this minus, we have n x bar squared. So it's the same thing as this one. That since x bar squared is equivalent to x bar multiplied by x bar, so plus n x bar squared. So now we can write this expression as this summation x squared minus n x bar, this x bar. So now we can write this x bar as summation x over n minus n, this n, we have x bar here. So we can also rewrite this x bar as summation x over n plus n x bar squared. So now, since this n cancel this n also cancel this n. So we write this as summation x squared minus x bar summation x. So that's what we are left with. When we cancel this one with this one, so we are left with x bar summation x. That's what we have here. So minus this n also cancel this n. We are also left with x bar summation x. That's what we have here. Plus n x bar squared. So the next thing is to factor out the summation. So we have summation here, summation here, summation here. We have n here, which is also equivalent to summation. So we take out the summation, we factor it out. So summation outside the bracket, we close the bracket, we now open the bracket. This x squared, that's what we have here. We have x bar, we have this x here, since summation is already outside. So minus x bar, we have x here, since summation is already outside. And we have x bar squared, since this n is equivalent to summation and that summation is also already outside. So this expression is equivalent to this expression. So the next is grouping. So we are going to group the component in this bracket into two. So we have the first group, this is the first group, and this is the second group. So we have x squared minus x bar x, that is the first group, minus x bar x minus x bar squared, that is the second group. So next, is to factor out each of the common element in each of the groups. So we have x common here. We also have x bar common here. So when we factor out this x here, so we have x outside the bracket, close the outside the bracket. So we open that bracket. So we have x left here minus, since we already factor out x, so we are left with x bar here. That's why we have x is in bracket x minus x bar. We close the bracket minus, we move to the second group. So we can see that the common factor here is x bar. So we take it out, so we now have x bar outside the bracket. We open the bracket, so we are left with x here minus x bar here. So we can see that this is equals to this. So we have summation here. So we can now write this as this everything as this, as x minus x bar. So we now have x minus x bar. So we can see that summation x minus x bar, close bracket, x minus x bar in bracket. So this x minus x bar moved by x minus x bar in bracket. So we can see that it's equivalent to x minus x bar squared. So putting the summation outside bracket, we have summation x minus x bar in bracket squared. So we can see that this expression, that is the denominator, is equivalent to this. So we have proved that this denominator is equivalent to this denominator here. So now we can see that this expression, that is summation x y minus n x bar y bar over summation x squared minus n x bar squared equivalent to summation x minus x bar in bracket y minus y bar in bracket over summation x minus x bar in bracket squared. This is the end of proof. See you in the next lecture. Thank you.